Can you hear me?
Yeah.
Yep. Thank you. Let's wait for a few more minutes. Maybe somebody else will join and we will start. Okay, I'm going to share a link to this document into Zoom chat. Please feel free to open and add your name into attendees list. To have the opportunity editing this document, you need to open this Google group, click join, and in a while you'll get access to read and write into this document automatically. Yeah, please put it not here, but here. Today we have March 5. I'm Andrei Kvapil. I'll be hosting this meeting. So is there anybody new on this community meeting who didn't introduce yourself previously or who would like to put few words about themselves?
Hello. My name is Maxim, and I'm a Cozystack contributor. And before I spent a couple of years building an internal developer platform at one big retail company, where we served about 100 teams.
Awesome. Thank you. Welcome to our community. Is there anybody else?
And welcome to our team.
We didn't hear you, Alexei. You probably have some microphone outside. All right, then I'll repeat that we have Telegram group, Cozystack, where you can join and ask your questions. And also we have Slack channel in official Kubernetes Slack. Feel free to join and let's switch to agenda. First, I'm new CozySummit. We are still waiting for your CFP, and please click RSVP to get to be notified when the event will be started. I will not miss the event itself. And today we have finally released version 1.0. There were a lot of changes. You can read the Cozystack version 1.0 changelog. The first and major change for this release was that we have migrated to package-based architecture. Now Cozystack includes some packages. It looks like we actually consumed Fluxcd repositories like Ubuntu repositories and made it possible to install packages just from these specially prepared repositories for Cozystack. This system is based on Cozystack operator and Fluxcd source watcher. Actually, we're just consuming the logic of Fluxcd and the additional sugar logic to prepare and write the packages for Cozystack. In fact, it looks like Ubuntu distribution. Now you can use the same approach to deliver on the specific options of on the specific components of Cozystack into your Kubernetes cluster, or you can use Kubernetes, or you can use Cozystack as a ready platform as it was before. So for now, we're introducing two different approaches. The original one, when Cozystack can be used as a ready platform for ISPs, it actually includes the dashboard, all the set of applications, and everything is pre-configured for you. You actually not even need to change anything in this packaging system. And the option two, it's called, we call it build your own platform with Cozystack. This approach is focused on around the Cozy packaging tool, which actually allows you to install the packages, resolve the dependencies, and it more likely looks like a traditional Linux distribution. So in fact, in Cozystack, now you have two additional entities. It is package source, which defines the package for the Cozystack. It is also handled by FluxCD source watcher, which downloads the sources and makes them able to be installed by the package. And the package actually represents user requests to install the specific packages from the source. For managing this, we have created the Cozy packaging tool. Now it can be easily installed from the Brew. We also have our Brew repository, thanks to Alexei, who actually created it. Yeah, sorry for my network connectivity. Sometimes it might be difficult, might be long to build and run some pages. Not sure if we have this specified in our documentation already, but in fact, you can use BrewTab, and then you can install any tooling for the Cozystack from this repository. All right, so now there are also a few other changes. We finally introduced a read-write many support for tenant Kubernetes clusters. This is done by modifying KubeVirt CSI driver by adding additional linstore specific wrapper around it. And finally, you can order PVCs in your tenant Kubernetes clusters, which are RWX and fully support snapshots and cloning. Actually, under the hood, they use NFS server, which directly passes through from the NFS Ganesha managed by linstore itself into user tenant Kubernetes clusters. A few other options. We finally redesigned the application set. We have a few applications which are now deprecated. We have deprecated FerretDB. The new Cozystack also introduced Quadrant, also Harbor. I don't have it here because it is release candidate 1. I didn't update it yet. And the next version also will introduce OpenBow as a managed application. The virtual machine gets removed. Finally, we decided to leave just two entities to not repeat themselves. So for now, the virtual machines can be managed by these two entities, actually virtual machine disk and virtual machine instance. Virtual machine disk allows you to import existing disks or images. For example, you can create images from Ubuntu, cloud images, or any other distributions. You can upload ISO, and upon of them, you can create virtual machine instance, which will just execute them. Of course, virtual machine instance support passing through GPUs, but that was and even before. We've introduced a lot of fixes. Actually, dashboard started behaving way more better. Right now, it also includes some drop downs for the application, so you can choose the specific instance types. I think I didn't update it yet, so instance types. Oh, they are here. So now they are automatically loaded from the Kubernetes API and substitutes into this drop-down list where you can just click and choose the specific instance type you want to use. So if you, as administrator, you can add your own custom instance types, and users will be able to see them and consume for creating their application, their virtual machines. Please be aware if you're running production. For now, we continuously fixing our migration scripts. One is not very simple. Sometimes you can find the bugs. We get actually some experience when monitoring application was redeployed. We probably fixed almost all of them, but be aware and please report any bugs if you face too. Finally, we introduce support for non-Talus Kubernetes distributions. We still trying to keep with Talus as a main choice for deploying Cozystack because Talus allows us to hard code kernel modules and kernel itself, so we can be sure that it will be working the same way like in our pipeline in your end environments as well. But regarding this, we also added generic Kubernetes distributions support. For this, we created the guide where you can install Cozystack on K3s, Kubernetes, or even KRK. Also, we are almost ready to provide you Ansible playbooks. Unfortunately, I don't have a link here. I'll try to find it in our repository.
Is it possible to hear me now?
Yeah.
Yeah, you can find this repository in our organization. It's already done. Everyone can use it. Yeah, it's here. And I'm facing some requests about secure boot for Cozystack. And now it's possible. Since we're using Helm to install the Cozy above any generic Kubernetes, anyone can install preferred operating system with secure boot enabled and use it as a base for Cozystack. And you can choose at least two ways, using Helm or with one Ansible collection. With Ansible collection, including examples of how you can manage any clean instance of Ubuntu, or SUSE, or Rocky, or Red Hat, or something you like, and install Cozystack above it with using K3s in examples or any other Kubernetes installation you like.
So those Ansible playbooks, they will deploy K3s by default, am I right? And install Cozystack on them.
It's not hard-coded. Our installations as Ansible collection can be used with K3s. It's simple, and where Ansible collection is good enough, and we are compatible to their collection, but you can use it above any other Kubernetes you like. And examples, you can find the whole path, how to install K3s and Cozystack above it, but it's not mandatory.
Okay, cool. Thank you. And this boot is talking about, this is related to latest boot to Talus version, is
no, we still can't hack the UEFI and replace the kernel with something else. But if someone needs it, for example, it's PCI DSS environment or something, we can install any Linux distribution we like, and we can install Kubernetes and Cozystack above it. So if you need secure boot, you can install your oven's operation system with secure boot and use it.
Got it. Thank you.
Also, we are working to handle secure boot for our towers, but it's still in progress.
Thank you. All right, let's switch to the next topic to discuss. We wanted to develop IDP bundle, and we have two speakers here. Really, Maxim have some presentation about how it looks like. Yeah, I would like to introduce first what the IDP is. Actually, IDP means internal developer platform. We have continuously getting requests from the developers that we don't want to understand your Kubernetes. We don't want to think about your Postgres, MariaDB, and things like so. I just want to put my code somewhere and just let it deploy it. All right. That's actually the request, and we have few options to discuss today. Let me introduce Maxim. He has some presentation for us and some experience.
Thanks. But before presentation, I want to say, Andrei, I agree with you about developers want to know about how to deploy to Kubernetes, about infrastructure. They want just to deploy code automatically after a commit. So I have, can I share my screen, please? Because
give me a second. I'll stop my sharing, and now you should have this opportunity.
5 seconds.
There should be green button share downstairs.
5 seconds, please. Because I have a problem with screen sharing. Yeah. Anybody see screen?
Yeah, we can see your screen.
So I enable. You see a presentation because I enable. Yeah. So after research team about developer platform, I want to introduce a concept about Cozystack developer platform. Is a thin layer for developer experience on top of the Cozystack ecosystem. So what is Cozy IDP? It's a glue for developer experience on top of Cozystack. What IDP does? It provides application custom resource as a single entry point for developers, and CLI wrapper that provide some features over Kubernetes API, automatically providing secrets for the applications workloads, data plane concepts that handles placement for workloads, and a unified user interface based on current Open Web UI. What IDP not to do? It doesn't re-implement the wheel. It doesn't make custom UI. It doesn't make new managed services. All is based on current services in Cozystack. So what developers actually want? Developers don't want think about environments, about infrastructure, because he wants to actually develop his applications and deploys to production, to development or preview environments. So in development of platforms, we have two approaches: environment first and applications first. So environments first, it's actually current state of Cozystack. You create a tenant, create a clusters, somehow write deployments and deploy to the actually created managed Kubernetes cluster, manually provide secrets from managed services, configure your ingress, and connect to your monitoring. Developers don't want this. So in application first approach, developers actually describe application, what services he wants to have. For example, his applications depend on Postgres, on RabbitMQ, and the platform actually provides and deploys workloads. So what design principles I actually have? Cozystack based, reuse all operator solutions, and minimal custom code. The second is my personal principle, no backstage. Because I have some experience in backstage from my job, and at some point we fully rewrite UI and API server because backstage it's heavy. The next is Git agnostic because some users have GitHub, some GitLab, or Bitbucket or something else. So because of this, I want to API first, no GitOps for developers, not required for developers. And final principle is zero CozySummit for developers and full for ops. So when I design a developer platform, I see some of custom resource or entities. So application custom resource is just a fabric for creating your applications in environments. So environments, it's just a lifetime archer for handling life cycle about Kubernetes clusters, managed services, and workloads. This is required, for example, for preview environments. So creating additional tenants for each environment is so expensive. So data plane custom resource is just managed Kubernetes abstractions that create managed Kubernetes with some components that's required for running developer platform. And additionally, we have a Git provider custom resource for actually connect your source control systems, source control manager for like GitLab or GitHub or something else. For example, I love Gitea, and secret bindings. That's just provide from managed service secrets to the application. So go next. This is example about application custom resource. This spec is not actually complete. It's just a draft. So what he has, it can have. Sorry. It has options for provide existing repository and provide access token. So after all, platform can handle this repository and provide some services. So services property, where you define what services needed for your application. configuration for environments, like, hey, we want to in dev one replicas, but in production where we deploy it, we want to have 3 replicas, and enabling preview environment when he created when you have pull requests. So this is actually a factory that creates application instances. So environment custom resource, it's just yeah, Henry.
Yeah, I have a question here. Is it intended to be deployed in the same Kubernetes cluster or two different, like dev in dev Kubernetes cluster and prod in production one?
At current design, class data planes is one environment to the data planes, but data planes can handle multiple environments. Actually, why? Because if you provide, for example, multiple one environment to multiple clusters, it's a problem to handle network connectivity between clusters, but in same environment. So I simplify this. Yeah.
Okay, so I think this can also be handled by creating 2 separate payment services. If you need to have separate clusters, you just create one for dev and one for prod.
Right? Yeah.
Okay, thank you.
So
this
is actually a draft. In some moment, I want to create a pull requests with design document and contributions, and some discuss are welcome. So environment custom resource, it's just a lifecycle archer. For example, you want an environment for developer, for dev environment, staging and production. It usually has a data plane. So, and he can be, this environments can be ephemeral, like create environment based on webhook or pull requests or something else. So next concept is data plane. Data plane, it's actually where you want to deploy your application. It's just created under the hood managed Kubernetes. It has some components like ingress controller or gateway API controller, horizontal pod autoscaler, CAD, or something else. So in this slide, we can see
Yeah, sorry, I have a question. It's the set of the resources created should be the same for all the kind of applications, because I think I saw some Knative and OpenFaaS approaches. They actually build it from application templates, and they hold specific resources which should be created. Not sure which level of the customization we should provide here.
I don't think about it at current moment, but having templates for the applications, it's a good option. But at current moment, I don't think about it.
Okay, thank you. Please go ahead.
So the next it's actually Git provider. It's very, very simple. Just provide URL to your Git storage, for example, Git, GitHub, or GitLab. Provide credentials. It can be created via CLI. It can be created by Kubernetes administrator or developer. So I'm going to next. So preview environments. It's actually ephemeral instances that have workflow like you opened pull requests. So environment custom resource created. It's actually creates application instances and database and secret binding. And after pull request is closed, environment with all resources actually deleted. So we can see previous we have services. So what actually is services? I want to provide for Kubernetes administrators extension point how to provide services for the actual developers. So we have kind of service definition. He just has some values in a developer's custom resource, and he is actually mapped to the Postgres instance, for example. And after fetch the secret and push them to the application. So secret binding for auto-varying credentials. So how to provide credentials for the connection for Postgres or something else. So it's just, for example, external secret operator has push secrets that create a secret in OpenBOW or, for example, in other Kubernetes cluster. So we create special secret, like, for example, service name and platform secret. And we have the environment from, we actually load all values from the secret. So I think it's simple. So I'm going to next. So what about configure application? I think about it in some time, and I think we should have two modes for the application. We want to have opinionated Helm chart by default, where you can configure your resources, scaling parameters, your ingress, or something else, or provide custom Helm charts for configuration of your application. So after all, I speak before that I want to have a API first approach. Because I want to implement CLI for the developers, such just a very simple wrapper about over Kubernetes API. Because developers don't want to make a pull request to the infrastructure repository and waiting for review for creating, for example, his applications. He want actually create his services, deploy to the development, and that's all. So I have statuses in the application's custom resource. He can use, for example, in CLI or in our user interface. For example, we are having URLs to the observability stack, for example, to metrics, to logs, or to alerts. We can via CLI getting logs, alerts, or status of deployment. So we have URL to the environment, and something else in the future, because it's actually a draft, not a final vision. So next, I want to talk about Git agnostic, but actually users want to have some process for building his application and something custom logic. So I think we should provide continuous integration as a service. So we can write some wrapper at top of Argo workflows or Tecton pipelines and connect them to via Argo events. For example, when you create pull requests in GitLab or Git, Argo events fetch this pull requests and starts pipelines that's actually build your image, deploy to the image registry, and deploy a new version. So in the final, what developer sees? Three concepts. My application is actually a CozyDP init and deploy, and the factory creates everything they needed. It's actually deploy his application. So my environment, developers want have environment for developer, for development, for production, and see what services actually run in what version. And he wants to easily have services. So I have unanswered questions about preview environments, observability, engineer flow, and data plan and delivery. That's all. Any questions, please? Yeah, Daniel.
Hi, thank you for your presentation. I want to know, you say developers don't want to mess up with infrastructure and so on, but who would write CI, builds, deploy scripts, configurations, and so on, in your opinion, for this system?
In my opinion, we should have, doesn't show in this presentation, but in my opinion, we should have, for example, in CozyDP init, we should provide templates for these applications where we have already configured CI/CD packages, some boilerplate codes, and something else. Yeah.
So it will be provided by CozyDP.
Yeah, by CozyDP, we should have, for example, some registry about application templates. And actually, developer can use these templates for creating from actually boilerplate his services automatically.
Okay.
So because this is actually reason why we should provide our CI and not depend on GitLab CI or GitHub Actions or Git Actions or Bitbucket Bamboo or something.
Oh, it's my next question about, do you already use Argo workflows for CI in your work, or it's like concept?
It's like a concept because in my previous work, we develop a developer platform for one company, and he already used GitLab CI, and his concept like GitLab Actions, and we don't require for developing custom CI/CD solution.
Okay, thank you.
Maxim, did you hear anything about build packs? Because I think they actually allow you to
Yeah.
get rid of specific vendor stack like GitLab and GitHub, and keep the build local on the Kubernetes itself.
Yeah, I know about build pack and Railpack and the Nix pack and other packs, but in my opinion, some projects have a very customized CI/CD pipeline. For example, he on bare metal builds his application. After all, he's built a Docker image. I actually disagree with this pattern, but some users can have this option, and this actually needed a full-sized CI/CD tool, not just a internal builder.
That's an interesting approach, because always when we're choosing between the providing complexity, providing the flexibility for the user, or rather limiting them to have a few functions which actually works good, sometimes we can provide a better service for them. We were thinking about implementing IDP different way. Actually, my original idea was about using Git first approach when we have GitLab deployed as a main service for whole Cozystack. And anytime when you start creating new applications, Cozystack will create additional repositories inside of this GitLab. And it can create templates for the users, so they can actually manage and change this code, and in a while this application will be deployed. But for now, I found another solution which I really like. Yeah, if you can stop sharing, I can share even some screenshots from it, or even dashboard. The application called Epinio, and it actually allows you to do the thing which provides some sort of IDP as well. Epinio is community-driven project. It actually allows you to define the new applications. It has UI and CLI already enabled. So you can deploy application from various providers. It can be either Git URL, GitHub, GitLab, or just upload archive for the specific application. Then this application will be built from the build pack. There is image which will be used for building and pushed to the Docker registry. For now, Epinio works with its own Docker registry, and it ships with min.io, which I don't like. In our case, we already have Harbor, and I think it can be simply customized to use our Harbor instead. So in fact, user can specify what exactly they want to deploy. They can target it to the specific Git repository with the application. In a while, it will be built. The Docker image is pushed to the registry for the tenant, and then it will be deployed and available as a service here. Yeah, for now it is not working, but in fact, the application, it will provide you a route to this application. And I really like this approach because it looks like simpler for the developers. The only question is dependencies. I was considering to deploy Epinio to tenant Kubernetes clusters and create some additional bindings to have the opportunity to order managed services right from tenant Kubernetes clusters. So actually, we can provide the opportunity to order managed services from the Cozystack from inside of the tenant Kubernetes clusters. So you don't need to change kube configs. You just work with your tenant Kubernetes cluster. Your approach, Maxim, is different. I guess users also don't have to change their kube config to switch the clusters, because they only communicate with Cozystack API in this way.
And I have a question about when users should have multiple Kubernetes cluster in actually in each managed Kubernetes cluster they have actually a separate Epinio instance or it can be shared.
Yeah, in fact, Cozystack is focused on providing managed services, and managed services is actually the thing which users can just consume. They don't need to manage itself by themselves. In fact, we have this marketplace with a list of applications. There are a lot of applications which are actually consuming Postgres, for example, or we have applications which use S3 provided from the CVDFS. Users don't see that. They just click the specific application they want to and install it. They don't care about what is installed under the hood. So from my point of view, we can just add the additional tile here, which will be called like Epinio. Under the hood, it will create another tenant Kubernetes cluster and deploy Epinio inside of it, and provide users the URL and instructions how to connect to the existing Epinio instance. In this way, they can get to access to the Cozystack itself. They can install this IDP solution, for example, Epinio or some other name, and simply start working with it. One more thing I like about Epinio, because it also provides you some service catalog. They provide default charts for deploying MongoDB, MySQL, Postgres, and some applications which we already do in the way of managing operators. In here, Epinio just deploys Helm chart, and I think even from Bitnami packages. But I think that this catalog can be simply rewritten to use our custom resources to run the applications. But we need this feature to make it possible to use inside of the tenant Kubernetes clusters. Otherwise, I have doubts about allowing users to actually consume management Kubernetes cluster. That might be also an option. So we can actually remove the Cozystack dashboard or rewrite this dashboard to have similar logic, and maybe use some better level of isolation for the user containers, for example, gvisor or kata containers. I know. But I really like this approach that anytime, yeah, as you call it, application first, or actually application-centric approach. When users don't think about the infrastructure, they think about their application and start thinking, okay, I need Postgres, I need Redis, I need S3 bucket, and they just specify it as in dependencies to their own application. I like this approach of build packs. I know that can't cover everything, but we already have some example of using Elastic API. For example, you can create application by just simply uploading PHP files or Java application and don't think about data plane at all. Yeah, if somebody in community have some ideas, please share them. We talking about IDP implementation, and we also very interesting to hearing your stories. If there is nothing to share.
I want to add about data planes. So data planes, it's actually for Kubernetes administrator users, not for actually end developers. So developers can create just environment for his needs and bind them to the already created data planes, not creating data planes from the developers. Yeah. And
yeah, I think we're also mixing terms a little bit because data plane is too wide term which can be used in different ways. When I was talking about data plane, I was talking about the specific runtime. Probably, I think I was wrong. I meant that user would want to upload their code and don't think about runtime. So they just choose their Java runtime version and don't think about how the code is deployed, how it is built. They just want to see if something goes wrong, like they want to get the output about that. All right, then let's switch to the other topic. There are just few notes about backups because version 1.0 also introduced very flexible and extendable backupping system. Unfortunately, we don't have anyone who can represent this topic right now. I think we can schedule it for the next community meeting. By the way, there is a pull request which creates the documentation how to use this backupping system. That might be a good start point if you want to try this functionality. Feel free to try and provide us feedback. We will actually fix the issues if you have some and clarify the documentation. We have 7 minutes left, and I would also consider talking about the CLI application for Cozystack. There is some generated code. I don't want to merge it as it is, but that might be a good exercise for anyone who would like to try working with AI agents. And actually, I would like to discuss the CLI for Cozystack itself. Many major clouds, for example, Azure or AWS or Google Cloud, they have their own CLI. Having its own CLI is a good opportunity also for using AI agents because they have more context on how to operate with the actually end cloud system. In fact, I want to have simple option to say to my Cloud Code, okay, here is CozyCTL, just create me a Postgres cluster with 3 users, create me Kubernetes cluster and deploy my application into it. In fact, I think it might be also very useful for the users to use CLI tool to create and start ordinary applications, ordinary actions like live migration for virtual machines, accessing it through the VNC or console. I have doubts about the syntaxes I'm proposing here. Please feel free to comment this pull request or share your thoughts. How can we make it more convenient? I'll keep this PR in our meetings, in our meeting minutes. Also, we could talk about the migration to Gateway API. We have 5 minutes left, not sure if we have time for that. By the way, there is an intention of Kubernetes to deprecate Ingress and Jinx controller. And we are thinking about the migration to Gateway API. We were thinking about the various options. I think we will choose to use Cilium and Envoy Gateway. either any pros and cons on, or using something else?
So I have a question. Cilium Envoy Gateway, it provides all features for Envoy, or have some less features?
I think it implements Gateway API in full, but maybe I'm wrong. I'm not big expert in Gateway API, and actually I don't know. I just saw that it is commonly used by our users. They even run it in their Kubernetes, tenant Kubernetes clusters. We were fixing it because it works slightly different way than standard Kubernetes services. But under the hood, I think this is like mainly common implementation of Gateway API. Maybe I'm wrong. Please correct me if I'm wrong.
No.
Actually, I don't know what impact would be from the perspective, or actually how many hours we need to spend for migrate, how it would be, how difficult it would be to migrate from Jigs Ingress to some Gateway API implementation. Yes, Johan?
Yeah, I have actually the maybe different thought that the only concern about Cilium, that it is owned by Cisco. So it's all owned by Cisco, and I'm from network background, and Cisco is not very good to open source. Not always, not always. So will be, some time when the open source Cilium will be will have one functionality, and commercial version will have another functionality, and that's probably concerning.
Got your point. I think Cisco doesn't own any Cilium. Cilium is actually CNCF project, but they own a company who has a lot of maintainers who are actually maintaining the Cilium itself, so they can make some impact on this. But there is also a good question: is can we support various Gateway API implementation? Because I think Gateway API actually tended to be similar for any provider, just like we do with MetalLB, for example. You can throw out the MetalLB and use Cilium instead of it.
Yeah, that's probably from networking point of view, the combination of CNIs in Cozystack is very complex. So, and we believe that from troubleshooting, it's better to have that one or another CNI do the all work. So if you need to kube and kube event, then why do not try to do everything with kube event? What's wrong with policies in kube event actually?
What's wrong with them?
No, that's why you decided to use Cilium only for policies and use kube event for everything else.
Sorry, I just missed that part. I think for now, the policies are working fine. We manage them by Cilium itself. I think Kube OEN, they depend on the native Kubernetes policies, which are not so flexible. That might be problem of the default API for Kubernetes network policies.
And they are not getting better, so they are not developed. They are not.
Not sure. I think we need to check this. Probably for now, we depend on Cilium just because of these network policies. And you're right. We need to check it out.
Yeah, I'm not against. Cilium looks like a very cool thing, and it is very popular, and the BPF is very very cool. But when you're looking at all that, you're seeing that all this going on different levels. That you think that okay, Cilium is doing something is below. And with combination with Talos, it's maybe not so convenient to troubleshoot all of that. And that's and network engineer always think how to simplify the whole network. And it's okay. Okay, if everything can be done with Cilium, it's fine. If everything can be done with KubeVirt, it's also fine. But it's if one thing, another thing, and another thing, and from only from network engineering. It's only from operations. It's complexity, and the question if it is possible to make it simpler or not.
I think that packing things into a single component will not make it much simpler, because actually, if we compare MetalLB and Cilium implementation, that's pretty similar. We just follow Unix topology, like we use the single thing which does the simple action and does it well.
Yeah, I understand.
There is a question from the chat, why we still using MetalLB and just don't use Cilium, because we want to be vendor neutral, and MetalLB, from my perspective, I think it is more production ready solution. It has additional options to high availability when Kubernetes API is not accessible, which Cilium does have now.
And
All right.
sorry, but I want to add that with Cilium and L3 BGP balancer have some troubles from my friends. Yeah, I think Metal is more stable.
Thank you for sharing this. Yeah, we run out of time. We don't have time for bug scrap and pull request review. Many thank you for joining our community meeting. There were a lot of people. Maxim, thank you for presentation, and see you in 2 weeks, same time. Bye-bye.
Thank you. Bye.
Bye-bye, guys. Nice to meet you all here.